And welcome to this next video from the Algebra and Functions section of the Year 1 part of the A-Level Maths course. And in this one we're going to be introducing an idea called factor theorem, which is quite a grand title, but it's actually a reasonably straightforward concept. And what we're going to do is figure out what factor theorem is, and then look at how you can use it, particularly when you're dealing with higher order polynomials, for example, cubics and potentially power 4 equations. So here we go. In the previous video, we did a bit of a division. We realised that x plus 3 was a factor of 2x cubed plus 7x squared minus 9, because when you divide x plus 3 into this thing here, you end up with a remainder of 0. So what we're going to do is just take that idea a little bit further. So let's say that for that function, which is the one we've got in the question at the top, if x plus 3 is a factor of f of x, i.e. if it goes in, then x minus 3 is a solution to the equation, which is to say that if we wanted to solve the equation 2x cubed plus 7x squared minus 9 equals 0, we could do some factorising. There's our factor of x plus 3, and from there we get x minus 3 being a solution. So what that tells us is that if I take my function and I put in a minus 3 into here, what I'm going to get out of this is going to be 0, because we know solution x equals minus 3 is a solution to this. It's a value of x such that this equation here equals 0, and it clearly does. And we could have made similar statements for the other two factors and their roots as well. So for the 2x plus 3 leading to minus 3 over 2, or for the x minus 1 leading to x equals 1. Now all factor theorem does, it just basically puts that into a kind of slightly more formal process, which is this. So if f of x is a polynomial, then if f of a equals 0, then x minus a is a factor. And the reverse of that statement is if x minus a is a factor of fx, then f of a equals 0. And the one key thing that we need to make sure we're very, very aware of is that change of sign thing. And you remember that comes from, if you've got a factor that's like x plus 5, then the solution is going to be x equals minus 5. And you've been used to flipping that sign ever since you first started using factorising to solve quadratics back at GCSE level. So let's just have a little look at how we're going to go about using the factor theorem. So here we go, here's an example. We've got a function g of x, and it says use factor theorem to show that x plus 5 and 3x minus 1 are both factors of g of x. So here we go. So first thing we're going to do is we're going to find g of a particular value, and for part 1 we've got our factor here, x plus 5. So the value we're going to use here, if x plus 5 is a factor, then g of minus 5 is a thing that's going to be equal to 0. So if we can put minus 5 into g of x, hopefully we should find that when we put it in, that value in, the whole thing should end up being 0. So let's go for it and see what happens. So g of minus 5 is all of that. And in the exam, as long as you just kind of show clearly that you're putting the values in, you don't have to work it out mechanically by hand. You can now just put all of that into the calculator, and what do you know, out pops the 0. And then here comes the important bit. You absolutely have to make the statement, because you've got to say that, tell the examiner, I know what this means, and what this result means is that x plus 5 is a factor. So the highlighted statement in blue absolutely must go in your exam, otherwise you're going to be dropping a mark. Okay, and it is as simple as that. So let's now have a look at part 2. What we're going to do now is think, well, if we're going to prove that 3x minus 1 is a factor, what would be our root coming out of there? And hopefully realise that coming out of there would be a third. So let's bang in g of a third. Let's put a third into it. Here we go again. There it is. And look, what do you know? That equals 0. And there's our accompanying statement. So what we've done there in part A is just subbed in a relevant number, shown that it equals 0, and then made our statement say that, okay, x plus 5 is a factor, or for part 2, 3x minus 1 is a factor. Hopefully that's reasonably straightforward. Thing to note, just in the exam, 9 times out of 10, it will be you're just in with a factor that's just an integer, rather than something like this one here where you ended up having to do a fraction. But just in case, I included this example here, just so we're okay to deal with something like this if it comes up. Okay, moving on to part B, it says, right, g of x is a product of 3 linear factors. Well, we're told we've got 3 linear factors and we know 2 of them. So we know that our third factor is going to be a linear factor, so if it's a linear factor it can be written in the form ax plus b. There's our standardised general form of a linear factor. And so what we're going to do is figure out what a and b are. So let's take g of x and write it with our three linear factors. There they go. And so what we're going to do, as I said, is work out a and b. And the simplest way to do that is just have a little look at what we've got on the left hand side over here, and it equates to, and this thing here is equivalent to, the three lines and equal sign means equivalent to rather than equal to. What it means is this stuff on the left is equivalent to this stuff on the right for some values of a and b. Now don't worry massively about that one. Nobody's ever going to pick you up on the fact you use only two lines and equal sign rather than three for an equivalent to sign, but I just thought I'd put it there just to make sure I'm being mathematically correct. So here we go, let's have a look at the x cubed coefficient. And the x cubed coefficient is the 3. If we multiply out these brackets, that 3 must have come from multiplying that one, that thing there, and that thing there. So that's the only way we could have got an x cubed term coming from our linear brackets. And so what that means is this 3 here has got to have come from doing 3 times 1 times whatever value that is. And so straight away it's clear that our value of a is going to be a 1 in order to make that work. Likewise, let's have a look at the constant term and use that to find out what b is, because there's our constant term, and that will have come from multiplying the three numbers at the end, the -1, the +5, and whatever number that is. And hopefully already you're quite clear to see that we're going to get a b equals -2 coming from there. So there we go, there's our values for a and b. So therefore it says write g of x as a product of three linear factors. So just stating a and b wouldn't be enough, we'd have to physically go and write the three linear factors, and there they are, there's your answer. Okay, moving on. Normally you get given the thing that you're trying to prove. So in the previous quote it says prove that x plus 3 is a factor, and so you normally get given that as a start, but on the other occasion you might just say, okay, we've got to solve this, in which case you've got to try and figure out what numbers you're putting into factor theorem to begin with, and that's going to come from the constant term on the end. So if we have a look at that value there, the numbers that are going to be in our brackets have got to be factors of 6 in order for it to work, in the same way that when you started factoring quadratics it was the two numbers on the end that multiplied to make the term and then added to make the one in the middle. It's the multiply to get the ones on the end we're interested in here. So what that means is we're going to try those values into our factor theorem, ±1, ±2, ±3, or ±6. They're the only things that are going to be able to work here. So off we go, let's try ±1 to begin with. Put in the 1 and we end up with that, so that's 2 times 1 cubed plus 1 squared minus 13 times 1 plus 6. Turns out that doesn't equal 0 at all, so that one's no good. So that means x minus 1 is not a factor. So let's try it with f of -1, see if that works better for us. And as it turns out, that one doesn't work either. So that means x plus 1 is not a factor, which means we're not going to get a 1 from there. Okay, let's have a go with f of 2. So let's put that in, and straight away we can see, yep, that one equals 0. Happy days. We found one that works. That means that x minus 2 is a factor. So we don't need to keep going with this, because now that we've got x minus 2 as a factor, we can start using that fact to break this cubic down into the product of a linear and a quadratic factor. I'm going to do that via division. Most people go for division, but if you prefer to, you can do this by inspection. I'm not going to do this in this video, but it might be your teacher can show you another way around it that's just a little bit shorter, but most people do go for division. So here we go, let's do the long division. Off we go. So we've got 2x squared, lots of x minus 2 goes into there, and there goes our subtraction. 4x minus, sorry, try again, x squared minus 4x squared is 5x squared, bring down to minus 13x. Off we go again, so we need a plus 5x, there it is, do the subtraction, minus 13x minus 10x, gives us minus 3x, bring down the plus 6, and there we go. We can see we've got a remainder of 0. So straight away we can say that our quadratic can be written like that. So there's our linear factor and there's our quadratic factor we just discovered, and now it's just a case of doing some solving with that, or sorry, some factorising on that, and there you go, and therefore that allows us to solve the equation. So we've got x equals 2, x equals a half, and x equals minus 3. Last thing to say before we move on from here, obviously, is just we've done this via division to be able to get the quadratic factor. It might be that you've got a calculator that can do a bit of solving for you, so you might be able to use your calculator to get that to come out. But having said that, my warning always when I say, well, let's use the calculator, is the exam boards know you've got the calculator, so if they want you to have to do a long division somewhere along the line, they will find a way to be able to get the question phrased, which means you won't be able to do it on the calculator. So you do need to make sure you keep those skills alive and don't just rely on your calculator. I think more and more we're saying that we can use the calculator to check things are okay rather than to actually do the work for us. Right, okay, so one last example that I'm going to go for. So here's a problem solving type of question. So we're given x plus 4 and x minus 1 are factors of a cubic polynomial. Find the values of a and b. So we've got our x squared coefficient and our x coefficient, which we don't know. So we've got to try and figure out what they are given the information we've got here. So again, let's start off by using a bit of factor theorem, and let's go for the fact that from there f of minus 4 equals 0. So that's the first bit of information that we're given, and if we take exactly the same principle with the second piece of information, we also know that f of 1 equals 0. And so what we'll do is let's just start plugging some numbers and using our two facts to create a couple of equations. So here we go. F of minus 4 equals minus 128, so there's minus 64 times by 2. Minus 4 squared is going to be positive 16, so that gives us 16a. And we've got minus 4b plus 12, and that all equals 0. Bit of tidying up there, so we're going to combine the minus 128 and the 12, and then do a bit of dividing, so the whole thing will divide by 4. We end up with 4a minus b equals 29. And hopefully you can see where we're going with this one. We're going to end up with a simultaneous equation. Let's do exactly the same thing with f of 1. Plug it in. Bit of tidying up. There we go. We've got a plus b equals minus 14. There's our pair of simultaneous equations. So the easiest thing to do now is just to add those two things together. So we end up with 5a equals 15, giving us a equals 3. And if a equals 3, we have got b equals minus 17. And there you go. We've solved the problem.